In this movie, we'll look at the distinction between objects and classes. We talk about object-oriented programming languages, but when you come to develop code in an object-oriented language, you find that you're defining classes, not objects. So what's the distinction? Objects represent individual instances of things in the domain. We abstract what these things have in common to create classes that represent definitions of the types of things in the domain. We use the classes to build software systems, and at runtime, there will be objects in the memory of the computer that collaborate to deliver the functionality of the system. Let's look at what this means. On the left, I have a copy of a book in my collection. I can document that book as an example object in my analysis of the domain that I plan to automate in a library system. From that book and others, I can abstract properties of books that are relevant to my requirements into a class. When the program is executed, objects will exist in memory and collaborate to provide the functionality of the system. The world is full of objects, and sometimes when we're analysing a domain, it's helpful to start with those objects. If I'm thinking of creating a system to catalogue all my books, I might start with the actual books. If I pick the books off the shelves, I'll find they have particular values associated with them. I have one book called Hadoop, The Definitive Guide by Tom White with a red spine, and another called The Alps by R.L.G. Irving with a green spine. Some of these properties may be useful, others may not. If I like to organise my books on the shelf in order of the colours of the rainbow, then knowing the colours of the spines is important. If I organise them by subject, then it isn't. From the individual books and their properties, I can abstract out the definition of classes that include the properties that I'm interested in as attributes. The objects model instances and the values associated with those instances. The classes model types and the properties that are common to instances of each type. The classes in the model go on to become the basis for the program code that's written to implement the system. This may be automated by generating code directly from the model, or it may be done by a programmer using the model as a specification. When the system is running on a computer, objects exist in memory, and through the functionality defined in their operations, collaborate to deliver the functionality of the overall system. Individually, objects only deal with their own specific responsibilities in terms of the data attribute values that they hold and the operations that they can perform. But when they interact with one another, we get the complex behaviour of the system as a whole. In this movie, we've briefly looked at the differences between objects and classes, and how we abstract from real-world objects to classes, and then implement objects in a computer system.